Hello friends, hope your preparation for upcoming KCET is going great. Today we are going to solve some of the MCQs from the chapter Electrostatic Potential and Capacitance, which can also be a quick revision on this chapter. So without wasting time, let us begin. If you are watching without subscribing our channel, please subscribe for more such videos. Let us start with the first question. 2-point charges of 12 microcoulomb and 8 microcoulomb are placed 10 cm apart in air. The work done to bring them 4 cm closer is. Let us draw the diagram. Let there be 2-point charges that is of 12 microcoulomb and 8 microcoulomb. The initial distance between them was 10 cm. So let me also write initial distance is R1, which is equal to 10 centimeter, and I can also write it as 0.1 meter. The work done in bringing them 4 centimeter closer. What if I get one of the charge 4 centimeter closer to the other charge? So 20 microcoulomb of charge is now with the other charge of 8 microcoulomb. So the distance that makes them to get separated is how much? It will be 10 minus 4, that is 6 centimeter. The distance between them is now 6 centimeter. Why? Because the charges are now 4 centimeter closer. I have brought 8 microcoulomb of charge to be 4 centimeter closer. That made the new distance between those two charges as 6 centimeter. What happens to the final distance? It is R2 is equal to 6 centimeter, or it is 0.06 meter. We made a note that the charges are now brought closer to each other, right? So what is the work done in moving this 8 microcoulomb of charge 4 centimeter closer? That work done is nothing but change in potential energy. Change in potential energy. What is the expression for potential energy between the two charges when they are at certain distance? E is given by, it is K is equal, U is equal to K, U1, Q1, Q2 by R. This is the expression we have. So let us now determine the potential energy between the two charges when they are separated with the distance of 10 centimeter. Also, the potential difference between the two charges when they are separated with the distance of 6 centimeter. That gives us the change in potential energy. Change in potential energy can also be written as UF minus UI, which is equal to work done, right? I can also write this as K, which is the constant, which is nothing but 1 by 4 pi epsilon naught, K into Q1, Q2, open bracket, 1 by R2 minus 1 by R1. One by R2 minus 1 by R1. So what is this Q1, Q2, K? We all know those values. Q1 is nothing but 12 microcoulomb. Q2 is 8 microcoulomb. So those values will be substituted and we get 9 into 10 to the power of 9, which is the value of constant K, and 12 micro is 10 to the power of minus 6. Q2 is 8 into 10 to the power of minus 6. Open bracket, 1 by R1 is 0.1 minus 1 by 0.06. So you can use the shortest method for solving the terms which are inside the bracket. So by taking 0.6 as the common one, and it will be 10 minus 6 in the numerator. Also, this part which is inside the bracket can be written as 4 by 0.6. So what are you going to get as the answer for work done W? That is what we are going to determine your work done, right? So what are we going to get inside the bracket is 4 by 0.6. Let me take it here, and 9 into 12 into 8 to be multiplied with the power that we are going to get here is minus 3. 10 to the power of 9, 10 to the power of minus 6, 10 to the power of minus 6 makes us to get 10 to the power of minus 3. Next, what about 4 by 0.6? We can also write it like this. I'll write the remaining part as it is. We are going to get 20 by 3. That makes us to get cancelled with 3 ones are 3 4 0 1. And the final answer here we are going to get is 5.760 joules, or 5760 into 10 to the power of minus 3 dividing with 10 to the power of 3, we get 5.760, which is approximately equal to 5.8 joules. This is the work done, which is equal to change in potential energy. So the closest answer for 5.760 joules is 5.8 joules. Hence option D is the correct one here. Hope you are clear with this. Let us read out question number 2. 4-point charges each plus Q is placed on the circumference of a circle of diameter 2D in such a way that they form a square. The potential at the center is. Let me draw a circle. Let us also say that the radius of the circle is d, or the diameter is 2d. There are 4 charges plus q. They are placed on the circumference and they are going to form the corners of a square. So the charges are now present at the corners of a square, and it is plus q charge at every corner of a square, and this is the center of the circle. So what is the diameter of the circle as told? It is equal to 2d. Hence the diagonal of the square is nothing but the diameter of a circle. So here we have 2d as the diameter. Diameter is equal to diagonal of the square. It is equal to 2d, right? Let us mark this center of the circle as O. What we have to find now is the potential at the center. What about the radius? As told, it is d, right? The radius here is nothing but d. What is the potential at the center of the circle here? It is due to all the 4 charges. Potential at the point is due to the system of charges here. I'll write potential at a point due to system of charges is. So it is nothing but V is equal to potential at the point due to the charge present over here, V1 plus V2 plus V3 plus V4. That is the potential due to all the 4 charges. What is the expression we have? It is V is equal to K into Q by R, right? So the total potential V will be equal to K E by R will be the common. Our R here is nothing but the D, value of D. So the charges will be Q1 plus Q2 plus Q3 plus Q4, or I can also write K by D, and the charges here are, they are all the same. We are going to write it as 4Q, or K into 4Q by D. But you cannot find this option 4Q by D anywhere among 4 given options, which makes us to understand that these options are given in CGS unit. Alright, CGS unit, in CGS system. In CGS system, we know that the value of K in a SI system, it is 1 by 4 pi epsilon naught. For CGS system, this value 1 by 4 pi epsilon naught is there, right? Which will be equal to 1 in CGS unit. That means we have to just find for 4Q by D. Hence the correct option is option B. Let me read out question number 3. If you are watching the video without subscribing, please subscribe our channel. Two charged spheres of radii 10 cm and 15 cm are connected by a thin wire. No charge will flow. No charge will flow if they have. So we have to choose the correct option from among 4 options. Let me think of two spheres of different radius. One of them has got radius say R1. The other one has got radius say R2. So we don't bother about the value of radius here. Let us say the radius of these spheres are different. These spheres are connected with the help of a thin wire. Make a note that charges will flow through the wire only if there is difference in potential. What makes the current to be flowing through the wire here? So these two spheres are already charged. They have told that the charges are there on the sphere. Let us say on the sphere of radius R1, the charge is Q1. On the sphere of radius R2, the charge is Q2. The charges can flow through this wire only when there is difference in potential, making this as the important point here. Current flows when there is potential difference between 2 points. That means charges, there is current flows from higher potential to lower potential, I can say. This is how the current will flow through the wire. Okay. Let us go through the options. The charges over them will be the same charge on each spheres. Okay, let us also assume that the charges over them is the same. That makes Q1 to be equal to Q2. Before that, I have already told that there should be difference in potential. Let us say the charges on them is same. We'll also write the potential difference. The potential of this sphere is V1. Potential on this sphere is V2. What expression we have for potential V? It is K into Q by R. Hence V1 is equal to K into Q1 by R1, or V2 is equal to K into Q2 by R2. Let us equate these two charges since Q1 is equal to Q2. This is according to option A. Option A says Q1 is equal to Q2. So if Q1 is equal to Q2, let me write it. Q1 to be equal to Q2, which is equal to Q. I'll write it as Q. KQ by R2. So we have made the charges to be equal. What we can understand here is If Q is equal to Q2, then there cannot be V1 and V2 being equal, right? So here V1 will be less than V2. Why? Because R2 is greater than R1. Since the value of R2 is greater than R1, which will make V1 to be lesser than V2. Since there is potential difference, V1 is at lower potential, V2 is at higher potential. That makes the charge from one sphere to be flown to the other sphere. Since there is difference in potential, even though the charges are same, even though the charges on each spheres are same, they can flow from one sphere to the other. Charges being on the same will not make them to flow over each other. Since there is difference in potential, the charge from Q2 will now flow to Q1. That is why option A here is the wrong one, which is not the correct option. Even though the charges are same, potential is different. They are at the same potential. Do you think that the potential being same makes the charge for not to flow? Make a note that no charges will flow if the potential is same. Charges will not flow over the sphere when the potentials are the same, which is very important to be noted. Charges being the same, we noted that potentials are different. If charges should not flow, or if no charge should be flown from one sphere to the other sphere, the potentials being the same, right? This can be the right option here, students. They are at same potential. Okay, let me move to the third option, that is same energy. So energy here can be nothing but E is equal to Q into V2, which is nothing but the work done. So I'm talking about the work done here. Work done is nothing but the electrostatic potential energy. So E1 is equal to Q1. E1 is equal to Q1 V1. E2 is equal to Q2 V2. Let me say that the electrostatic potential energy is the same for both the spheres. This is for option C. If I say E1 to be equal to E2, Q1 will be equal to V1 is equal to Q2 V2, which also makes us to understand that V1 is not equal to V2. They cannot be the same, right? There is difference in potential. Since there is difference in potential, the charges flow. Here the charges flow. Since here the potential difference is different, charges flow. What about the fourth option? The fourth option says, option D says, the field on their surface is same. What is the expression for field? Is equal to V by R. So let us assume that field on both the surfaces is the same. I'll write the potentials as V1 and V2. If E1 is equal to E2, then V1 by R1 is equal to V2 by R2. Since R1 and R2 are not equal, V1 and V2 are also not equal, also makes the charges to flow. So in all the three options here, we have found that charges being equal made the potentials different, energy being same made the potentials to be different, field being the same also made the potentials to be different. Got the point? Potentials are different for the options A, C and D, and we have proved it. What about option B? Charges are not going to flow only when there is same potential. That is why option B is the correct one here. Even though you don't prove this in the examination, these things, even though if it is not proved, you can directly take option B as the correct option here. Because we know that the charges can flow through this wire only when there is difference in potential. Hence, being same potential makes them for no charges to flow. Hope you are clear with this. Moving on to option 4. Electric charges of plus 10 microcoulomb plus 5 microcoulomb minus 3 microcoulomb and plus 8 microcoulomb are placed at the corners of a square of side root 2 meter. The potential at the center of the square is, this question is very easy to solve. Let us draw the square, and on the corners of the square we are going to place the charges. They are plus 10 microcoulomb, plus 5 microcoulomb, plus minus 3 microcoulomb and plus 8 microcoulomb. The length of each side of the square is root 2. What is the question? We have to find the potential at the center of the square. Let us mark the center of the square as O. Since we know the sides of the square, the measurement of each side of a square, we can find the measurement of the half of the diagonal. First, let us find the length of the diagonal of a square. That is by using Pythagoras theorem. Right? So, on using Pythagoras theorem, AC square is equal to AB square plus BC square. What we are going to get here is root 2 the whole square. Root 2 the whole square is equal to 2 plus 2. That makes it to be equal to 4. AC square equal to 4. AC is equal to 2. What about AO? AO is equal to OB is equal to OC is equal to OD. Their measurement will be equal to 1 meter. Right? Hence, we got to know the measurement of half of the diagonal. Our next thing is to find the potential at the center of the square. Potential at the center of the square due to all the 4 charges. Here we are going to use V is equal to potential at the point O due to the charge present at A, there is VA, charge present at B, charge present at C and charge present at D, makes them to have different potential. So we are going to use proposition principle to determine the value of potential at the center. So what formula we can use here? It is K into, what is the distance? It is R, and the charges are QA plus QB plus QC plus QD. Right? The charges present at the 4 corners. K is 9 into 10 to the power of 9 divided by R is 1. The value of QA is 10 microcoulomb. I write plus 10. Value of QB is 5 microcoulomb. I write plus 5. QC is minus 3. QD is plus 8. Hence, the total charge here is 9 into 10 to the power of 9 into 20. It should be in micro. The charge is in microcoulomb. Hence, the answer is 180 into 10 to the power of 3. Or, if we have to match the answer with the 4 options, it is 1.8 into 10 to the power of 5 volt. Hence, the correct option is option C. Moving on to the last question for today. The voltage of clouds is 4 into 10 to the power of 6 volt with respect to ground. in a lightning strike lasting 100 milliseconds, a charge of 4 coulomb is delivered to the ground. The power of lightning strike is, so what is given in the question? Voltage of clouds is given with respect to ground. What it is? It is 4 into 10 to the power of 6 volt, and there is a lightning strike and it was lasting for 100 milliseconds. The time for which the lightning occurs is simply 100 milliseconds, or it is 100 into 10 to the power of minus 3 seconds. I can also write this as 0.1 seconds. A charge of 4 coulomb is delivered to the ground, hence I can write Q as equal to 4 coulomb. So using these data given, we have to find the power. So we are going to use different formulas. Power is given by the definition, which is nothing but work done by time, W by T. This W can also be written as energy. Work done is stored as energy. There is U by T. So what is the expression for U that we can take here is energy stored in the capacitor. Is there right? The same energy stored expression is going to be considered. U is equal to half CV square. We know the value of V, that is the potential, but we don't know what is C. How do we find the capacitance? We know that C is equal to Q by V. Using this, we can easily find the value of C. Let me do that first. What is Q? The charge here is 4. Potential is 4 into 10 to the power of minus 6. 4 into 10 to the power of plus 6. It is 10 to the power of minus 6 farad. We got the value of capacitance. Now let us find the value of energy stored. Half C is 10 to the power of minus 6. V square is 4 into 10 to the power of 6, the whole square. What answer we are going to get here is 8 into 10 to the power of 6. On calculation, we got the value of energy stored in joules. So this energy stored needs to be substituted here. 8 into 10 to the power of 6 divided by 0.1, or it is 80 into 80 into 10 to the power of 6, or it is 80 megawatt. Hence the power of lightning strike is 80 megawatt. I hope this video lesson is helpful for all the students who are preparing for your examination. Subscribe our channel for more such videos. All the very best for your examination. Thank you for watching.